we are going to solve exponential equations and inequalities that have one variable in them, and it is going to be based on some fundamental properties. So if you have an equation that has a variable as an exponent, there is a special property that we can use to set up another equation. So if you have an exponential equation with a base b, if you know that b to the x power equals b to the y power, so the bases are the same, okay, then, and I'm going to put a double-sided arrow. Do you guys remember the phrase if and only if from geometry? Okay, so the if and only if works forwards and backwards. So if you have an equation where the bases are the same, okay, what follows is that the exponents also have to be equal. Okay, so the rule is if the bases are equal, then you know that the exponents are equal. Okay, because whatever your base is, if this power was 5, right, they would have to be equal to each other. Right? 2 to the 5th has to equal 2 to the 5th. It couldn't be anything else. So whenever you have an equation, what you want to try to do is write it with the same base wherever possible. That is going to be our goal today. Okay? We want to rewrite equations with the same base whenever we can. And that's because, according to this property, if the bases are equal, then we know the exponents must also be equal. Okay? So, let's look at the bases in example 1, part A. We have 9 and we have 27. Okay? So, can I rewrite 27 with a base of 9? 9 to what? So 9 to the 3rd equals 27?
No, absolutely not.
Yeah, okay, so 3 times 9 is, but not the 9 itself. Okay? Okay, so you could rewrite 27 as 3 to the 3rd. You could rewrite 9 as 3 to the 2nd. So these should always be equal. 3 squared is 9. 3 to the 3rd is 27. So this is a no calculator section, this part of 7.2. I know I put that on the board when you came in, but let's just start at. Just so there's no confusion. Okay, and then when you rewrite 9 as 3 squared, you're still going to have this exponent, 8 minus x, and you're still going to have this exponent, x minus 3. So whenever you have a power to a power, you multiply the powers. So when you multiply, you are going to be distributing. So when you do that, you would have 3 to the power of 16 minus 2x. And on this side, you would have 3 to the power of 3x minus 9. Once you have the bases are the same, you can use this property. If you have the same base of 3, these two exponents have to be equal. Okay, so you know that 16 minus 2x has to equal 3x minus 9. Okay, and that is based on the rule, if the bases are equal, then the exponents are equal. Okay? Alright, so from here, it is just an algebra 1 problem, right? Get all your x's on one side. Yep, algebra 1 problem. Okay, so 25 equals 5x, divide by 5, divide by 5, x is 5. Now, could I have an extraneous solution for this type of problem? Why not? that's not why.
You just got it.
Yeah. So, like if you had an odd root, yes. So, when we did have to check for what type of roots. If you had an even root, then you had to check. You have an even root when your exponent is what? Not 2, but not 3. Getting worse. Well, how do you write an even root? How do you write an even root as an exponent? 1/2. Okay, so I don't have a fraction. Okay, so 1/2 is the square root. Okay, and then so the reason why we had to do that is because the domain wasn't all real numbers. When you have exponents, if you don't have a fraction or if you don't have a root, then it's all real numbers and you don't have to worry about there being extraneous solutions. Okay? So it's all about the domain.
There's no fractions in like the exponent.
Yes. Right. Like if you don't have an exponent that is just a fraction. So all of your exponential functions should have an x in the exponent. Okay, so it's not going to be a fraction for these. Now, you have 4 and 32. So again, the first thing you should ask yourself is, can I rewrite 32 with a base of 4? No. But can I rewrite both of them with the same base?
Yes.
Yes. What would be the base for both? Yep. So think about what is equal to each one. So 2 to what power is 4? Squared. Okay, and then 2 to the 5th. All right. Now, I'm also fine once you rewrite the same base, if you want to distribute and then put the exponents equal, that's fine. So 2 times 5x is 10x. 2 times 1 is 2. Okay, so all we did is distributed here. You don't have anything to distribute there, so you're going to solve for x. And it's okay if your answer is a fraction. Okay, it's not always going to be a whole number. So 3 over 10, that is a reduced fraction. You can keep it just like that. Okay, if you wanted to write it as 0.3 because you know that's the tens place, that would be fine too. It's just a no calculator section, so most of you are going to keep it as a fraction. Okay, now, on this side we have 2, okay? You cannot rewrite 2 with anything other than 2, okay? It's just 2 to the first power. There's nothing else you could write it as. Now this one you have a fraction, but remember, we just said 2 to the 5th is 32. How do I get the 1 on top? Yep, good. So it's 2 to the negative 5. Okay, so you will have some where you have to do the negative to make it a fraction. And then once you have the bases are equal, you can set the exponents equal. And then we're going to solve for x. And make sure that your fraction is as reduced as possible. Okay, so negative 6 over 4 should not be your final answer because you should reduce it by what number? 2. So if you divide each by 2, this will be your final answer. Okay, do you guys think based on what we did for part C, you could do part D? Okay, so if you're having trouble getting started, the first clue is you have the 1 on top, right? So that means what type of exponents are you going to have? Okay, so if you're having trouble, if they're both fractions, just look at these. You have 5 and 25. Can you rewrite both of those with the same base? Yeah. So this is going to be 5 to a power. This is going to be 5 to a power. Can you guys put the powers in and then distribute? 2. Plus me.
Jesus, this is
Okay, so 5 to the negative 1 is how you get 1/5. 5 to the negative 2 is how you get 1 over 25. So now we're going to distribute, and we would get negative 2x is equal to negative 6x plus 12. Double check that you remember the negative times the negative. And then you're going to get all the x's on one side. And your final answer should be 3. Okay, now the only other thing we're learning today is how to do this with inequalities, and it is very, very similar. Okay, so the property of inequalities for exponential functions, you have 2 rules. So if you have b to the x is greater than b to the y, that is true if and only if. Did you guys ever use the if and only if like this or no? The IFF? Have you seen that before? So some of you have and some of you haven't. Interesting. Okay, so if you have that, keep the sign. So if it's greater than, x is greater than y. Okay, and then the same thing holds true if it's less than, and the same thing holds true if these have an equal to, so you just apply that. So if you have b to the x is less than b to the y, that's going to be true if and only if x is less than y. Okay, and again, if there's an equal to, that's going to follow as well. Now, the one thing you have to remember with inequalities is there's a special case where the sign flips, and that's if you do what? Divide or multiply. So multiply or divide by a negative. Okay, so the first part of this is the same thing that we just did. So here we have a base of 6. Here we have 1 over 36. So we can rewrite both of them with a base of what? 6. So this one's going to stay the same. This would be 6 to the power of negative 2. Yep, so 6 squared is this. And then greater than. And then, like I said, I'm fine if you just distribute at this step. So you have negative 12x. Negative times a negative is a positive. Greater than 3x minus 9. Okay, so the base isn't going anywhere. The only thing that's happening is you know if the bases are equal, the exponents have to be the same, and you can use that to help you solve. Okay, so generally I like all of the x's on this side so I don't have to flip anything around. This isn't the only way that you could do this. You could subtract 6 here. Okay, and then if you do divide by a negative, make sure that you flip the sign. If you move the x's to the other side, okay, then these would switch places and so would the sign, and then you could just flip it back when you write it. Okay, now remember, this is a no calculator section, so for 64, some of you might go to 8 squared right away, okay, and then maybe we don't know what 8 to the third is, it's not that. So if you don't have your calculator, what is a good thing to use? Yes, the factor trees are coming back. All right, so let's factor tree these up. So for the 64, again, you can choose how you do your factor tree. Like for 64, if you know it's 8 and 8, okay, then you could split it up that way and keep going. I think with some of you that aren't like used to doing the factor trees, it's a lot easier to start with a 2, a 3, or a 5, whichever one you have, because then you cut it in half. So 64 would be 2 times 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Now this is a little bit different than the way we used them previously. So what this means is I can rewrite 64 as 2 to what power? There's 1, 2, 3, 4, 5, 6. So this could be rewritten as 2 to the 6. So I could rewrite this with a base of 2. Let's see if we can do that for 256. Okay? Now, when you're doing the 256, work smarter, not harder, because when you split this in half, you have 2 times. When you're doing this in your head, do you do half of like 250?
Yeah.
Half of 250 is 125, and then half of 6, 3, so this is going to be 128, and then cut this in half. Half of 120 is 60, so this is going to be 64. Didn't we just do a factor tree for 64? So isn't 64 2 to the 6th power? So don't write all that out again, we just did it, right? So if you have 2 to the 6th times 2 times 2, that can be written as 2 to the 8th. Isn't that so much easier than trying to like guess and check and see which one is which? Maybe for some of you, yes. Maybe for others of you, if you know what those are. So I'm going to rewrite this as 2 to the 6th. Okay, and then 256 would be 2 to the 8th. Okay, and then you can distribute 6 times 4x, 6 times negative 8. Okay, and then we just distribute this side and then solve for x. Okay, so then we should get 16x plus 48, and when you move all the x's to one side, you'll get 8x. 48 plus 48 gave you what value? 96, and then when you divide by 8, if you're not sure what that is off the top of your head, remember, you can just ask yourself, 8 goes into 9 how many times? 1 time with 1 left over, so if you have 1 left over, you put it in front of the 6. 8 goes into 16 twice. Okay, and you don't have to do any sign flip because there is no dividing by a negative. Bada bing, bada boom. Okay? So I'm going to give you your homework, and then we're going to go over the 7-1 and then the 7-1 thing.